Let's look at question 19 in sample exam 3, Chem 11. This is a question in thermochemistry about enthalpy of formation and enthalpy of reaction, so the relationship between those two enthalpies. And the question gives you a reaction, and it gives you an enthalpy value at the end for that reaction, right? Negative 1196 kilojoules. And then it gives you values of enthalpy of formation for some of the species in the reaction. So it tells you the enthalpy formation for ClF3, which is the reactant, HF, the products, and then it says N2 and Cl2, which is these two species right here, are both in standard states. And then it's saying what's the enthalpy of formation of NH3. This requires you to remember a formula that was derived in class. And the formula is, if you want to calculate the enthalpy of change of a reaction, you can take the difference between the sum of the enthalpy of the formation of the product and then multiply, in this case, by the coefficient of that product, and then minus the sum of all the enthalpy of the formation of each reactant, and then again same thing, multiply by the coefficient of the reactant. So the way we can apply it in this context would be to say the enthalpy that we have for the reaction, which is the 1196, will then equal to the enthalpy of formation of each of the product multiplied by its coefficient. So I'm just going to write it out here. 1 mole of N2, so that's enthalpy of formation of N2, plus 6 moles times enthalpy formation of HF, plus 1 mole times enthalpy of formation of Cl2. So that's all the product side of things. And then we're going to subtract from that the reactant. So the reactant is 2 moles times enthalpy of formation of ClF3 plus 2 moles times enthalpy of formation of NH3. Now, if you notice what we have here, and then all of these is equal to the enthalpy of the reaction. Now, what do we know already? Well, we know this value. We know the HF, and then we also know the ClF3. We're being asked for this one, so that means that we're going to need to know these two as well, right? The Cl2 and the N2. But they told us that those are standard states, and if you remember what standard state means, is that their enthalpy of formation is equal to 0, okay? So that's how we're going to solve this, is basically we know all the numbers except for the unknown that we're being asked, which is the NH3. So we just need to isolate that on one side. So let's do that. So the delta HF of NH3, right, this is equal to 1 mole times delta HF of N2. Now that's just 0, okay, kilojoules per mole, plus 6 moles times the delta HF of HF, and that's going to be negative 271 kilojoules per mole. And then we have one more product, which is 1 mole times 0 again, because that's another standard state for our product. So that's all my product, and then I'm going to subtract from that. So this is originally here, right? When I did my algebra, I'm moving this guy right here, which is negative 2. I put it towards that side, so that becomes positive 2, and then I'll divide that 2 later in a second. And then so what's left is I'm gonna still subtract this guy right here, right? So minus 2 moles times the enthalpy formation of ClF3, which is negative 169 kilojoules per mole. And then remember that in the algebra, this thing is brought to the right side. If that's brought to the right side, then the sign changes. So the original value is negative 1196, so it becomes positive 1196 kilojoules. And then remember that this whole thing would equal to 2 moles of delta HF of NH3. So since I just won one of them, I would take this whole thing that I have right here and divide it by 2 to give me just the delta HF of NH3, okay? And so let's do that calculation. And when you do all that, you get negative 92 kilojoules divided by 2 in this case, and so 2 moles of NH3, so that ends up being negative 46 kilojoules per mole for each NH3, and so that will be your final answer.